Welcome to this tutorial. We're going to build a Tetris game with React. And the first question you should ask yourself is React a good choice for making a game like this? And to be honest, I don't know. It is probably better to build it with vanilla JavaScript, but I wanted to do this for myself to test how this game can work out with React. And sometimes I do this kind of projects just to, kind of expand my knowledge and try things out. And the idea for this started when I was looking at the tutorial at YouTube, where this guy creates a Tetris game with vanilla JavaScript. And it's in this channel that's called Method. And yeah, you can think whatever you want of that name. The tutorial is really good, actually. And I learned a lot because I have to say this, I'm not a game maker. I create web applications and stuff like that and web pages. So I'm kind of a rookie in game development, so it was fun to create this game with React and see how it works. And in this video, he used Canvas. I'm not going to use Canvas. I'm using regular divs and a grid for this one because I wanted to try that out also and not use Canvas. And it's also good to see how good React performs because there's going to be a lot of divs that we render to the screen because each cell in the Tetris game is a div. And I'm also going to borrow some of the code here, and especially the one where we're going to check for collision when we rotate our Tetromino, that is the name of the blocks in Tetris. Big credits to this channel, Method, and the video where this guy shows how to create a Tetris game in just, I think it's 50 minutes or so, yeah. And it's a really good tutorial if you want to learn how to build a Tetris in plain JavaScript. All right. Let's get to the app then, and here's the Tetris game that we're going to build. I choose to have kind of a retro style to it with these stars in the background. This is just an image I found on Unsplash. And we're going to show the score, the rows and the level, and then we have a start button. So if we press start game, we can play the game, and we're using the arrow keys on the keyboard for this one. You rotate the Tetromino with the up arrow, and you kind of go left and right with the other arrows, and down will make it go faster down there. And there will be some limitation in this game because this is not a perfect Tetris game. For example, the key input, we're just using the regular repeat here when holding down the down arrow key. There should probably be a better function for this where we can control the speed of this one. And also I will be using an interval for this one. We could also use request animation frame where we can create kind of a more controlled animation. So it will not be a perfect Tetris game, but it will be a good practice in React, and especially React hooks that so many people are talking about now on the internet. So we will be creating custom hooks, and we will use state, we will use useEffect and use callback, and also we're going to use React.memo for minimizing our re-renders of the cells. So I think this will be a good practice in React and especially React hooks. So let's get to it. We will start creating the game in the next video. We're going to start to build our Tetris game now, and we're going to use Create React App. And I actually use that one a lot because it's great for bootstrapping your project and you don't have to set up your Webpack and Babel config and everything like that from scratch. So I highly recommend you use Create React App. It's great. And we create a project by go into our console. In my case, I'm using Hyper. And we just type npx create-react-app. And we can call our application React-Tetris. This will create the folder that's called React-Tetris. And then press enter. And then we just wait. It will take a second here. All right, we're good to go here. And it's important now that you navigate into the new project folder you created. So type cd React-Tetris. And if we list the files, you can see it has created some folders and files for us here. And now I'm using style components for this game, so we have to install that one also. And we do that by typing npm I styled-components. All right, some arrows here, but I think we'll be fine. It's just on my computer. I can clear the console. I have also included some files in the starter files that you have to copy to your project folder, otherwise it won't work. So make sure, first of all, that you download the starter files. It's on GitHub and the link should be provided to you. And then in the starter files, you have something that's called bg.png. That's the background image, that the stars you see here. Then we have the font that's called Pixel. I found this one on the internet. It should be free to use, so I hope it is. And we have something that's called useInterval.js. And that's a custom hook that's created by Dan Abramov that I'm going to use when we create the game loop with the JavaScript interval. So we just have to copy this one over and I'll explain it later in the tutorial. First, grab the bg.png file, copy that one and go into your project folder. And inside the src, the source folder, we create a new folder that's called img. And that's for image, of course. And you can just paste the background in there. All right, then we have the font. So grab that one, copy that one, and create another folder inside of your src, your source folder. And we can call this folder font. Go inside of there and paste the font inside of it. And then we have the useInterval.js file. So copy that one. And still in the src folder, create another folder that's called hooks. This is the folder where we're going to create our custom hooks. So go inside of that folder and paste the useInterval.js file. And this should be it. This is everything we need to get us started. So in the next video, we'll start to scaffold out some components and we'll continue with our application. The first thing I do when I create the React application is that I scaffold out all the components that I need. And that's what we're going to be doing in this video. So first of all, you can see that we have a lot of files here that was created for us with Create React App. And we're not going to use some of this stuff here. You can delete it if you want. The logo, the service worker, the app test and stuff like that. Or you can just let it be because we're not using it now. We are going to use the app.js file here and the index.js file for now. And the index.js file, we don't actually have to touch that one. We can just go inside the app.js file. We can delete everything inside of there. So as usual, our application is going to start in the app.js file. This is kind of the highest component in the hierarchy. So we import React from React. We import Tetris from ./components/Tetris. Like so. And of course, this one, we haven't created this one yet. So we're going to create that in a minute. And we create our app function. I like to use arrow functions for this one. You can use a regular function if you want to do that. But we have const app equals parentheses. And we're going to create an explicit return for this one. So we just need parentheses. Then we can create a div with a class name of app. And we have our Tetris component. Like so. And then we export default app. And that's our app component. Then we can create a new folder inside our src folder that's called components. Inside the components folder, we are going to create 5 different components. So we can just create the file names now. So we create one that's called cell.js. Make sure you have a capital letter here to start with. Or maybe you don't name your components like that, but I like to name them with capital letter because it's a component. So we create another file that's called display.js. And we have a new file that's called stage.js. And we have a new file that's called startButton.js. And the last one is going to be the Tetris.js file. All right, these are our 5 components. The Tetris.js file is kind of the heart of this application. We can go into our cell.js file and start scaffold out this component. So we import React from React as usual. And we create the component const cell equals to parentheses. And we are going to have props for this one, so we can create these ones also. I destructure them out. We're going to have a type for this one, and we talk about this later on. We make an implicit return for now, and we can just have a div and can write cell inside of it. And we export default cell like so. So we save that one, and then we have our display.js file. We import React from React. We have a const that's called display equals, and for this one we're going to have two props. So we destructure them out. One is called game over and one is called text. And we create a div inside of here where we're going to have the text. So we create curly braces and text to grab that prop and display it inside of the div. Export default display. We will style these components later with style components, so we will change some stuff inside of them. We just scaffold them out now, so we know what components we're going to have for this game. Save that one. Then we go into our stage.js file. We import React from React. Of course, you can copy and paste a lot here also if you want to do that. For this one, we're going to import the cell component. So we import cell from /cell. And then we create a const stage equals to, and we destructure out the prop that we're going to have. That's called stage. And we make an implicit return for this one also. And as you can see, I'm not doing any prop type checking for this course. You can add that in yourself if you want to do that to verify your props with prop types. All right, we create a div for now again. And inside here, we're going to map through our stage prop and create cells from this stage prop. And we're going to do that later also. So we can just have a cell for now inside of this. And we export default stage like so. And we save this one. Then we have our start button.js file. So we import React from React. And we have a const start button. And we have a prop that's going to be a callback for this one. And we make an implicit return with a div that says start game. And we export default start button like so. We save that one. And then it's the last one. It's our Tetris component or heart of this application. So we import React from React like so. And then we're going to have some components here. We import our stage from /stage. We're also going to need our display from /display. And we import our start button from /start button. And these ones, we can check them out here. This is obviously going to be the stage with the cells in it. And these are the display components. We have 3 of them. And this is the start game button here. So these are the ones we've created now. Then we create our const Tetris and equals to an arrow function. And we have curly braces for this one because we're going to have more logic inside of here. And we can create the return statement here. First, we have a kind of a wrapper div here. And as I said, we're going to rename these ones when we style the components. Then we have our stage. And for now, we're not sending in any prop because we don't have anything to send in to it right now. Then we can create a side element. That's obviously the sidebar here that we're creating. And then we're going to have 3 different displays. And for these ones, we have a text prop. And for now, they can just say score. We can copy this one and paste 2 times. And this one can say rows and level. All right. We can also wrap these ones inside of a div. And we end it like that. And below we're going to have our start button. And it's going to get a callback prop, but we don't have that yet either. So we're not giving it that now. So this is it. And we export default Tetris like so. Okay. Then we can start this up to see what we've got. So npm start. And we have all our components showing up here, and that's great. They are, of course, not styled yet, but we're going to do that soon. First, we have to create the stage and our Tetrominos, and we're going to do that in the next video before we do the styling so we can see the UI here. Okay, we're going to create the stage and the Tetrominos in this video. And to do that, we have to create a couple of new files. Inside our source folder or src folder, we can create a new file that's called gamehelpers.js. And that's a lowercase g on that one, because this is not a component. And we can also create a new file that's called Tetrominos.js. Make sure you're inside the gamehelpers.js file. Here we're going to create a stage, and we are going to have two consts where we can set the stage width and height. And we have to import these ones into our components. So we have to export them from this file. So we export const, and then with capital letters, we can have stage width. And we can set that one to 12. And we export const stage height. And we set that to 20. So that's our width and height. But we actually need a function that creates the stage for us. And the stage is going to be a nested array, a multi-dimensional array that represents rows and columns. And we have to export this function that creates the stage also, because we're going to need it in our component. So we export const create stage. And it is an arrow function. All right, so how is this going to work? Well, we're going to create a multi-dimensional array that represents the grid. So we create an array from something. And that something is another array that we're going to create from the stage height. And this is going to be an empty array, so it's not going to be useful for us. So we have to do something. We have to fill this up with something. We can do that by supplying an inline function here. And that means for each row, we create a new array from the stage width, and we're going to fill it with another array. There's a lot of arrays here. And for now, we set it to 0, and we have something that's called clear. And these ones, I'm going to explain that later on. 0 equals nothing on the grid. We have the different Tetrominos, each of them going to have a letter here. So we know that the grid has that Tetromino in that particular cell. And we also have this clear property here that it's going to be set to merged when we have a Tetromino merge into the stage. That means when we have collided, so the Tetromino should stay in the stage and not be cleared in the next render. And as I said, I will explain this later on. So I hope you understand this function, what it's doing. We're creating a new array from an array that we're creating here with the state height. That's the 20 rows we're going to have in our grid. And we're supplying an inline function that for each row create a new array with our cells. And we're filling them up with this array here that has one value that is 0, and that's represent a clean cell. There's nothing in that cell on the stage. And we also have this string here that says clear for now, and that means that there's no Tetromino that has collided in this cell, and we should wipe it out from the stage in the next render. Okay, so that's how we create our stage. And if you remember up here in the components, we had our stage here, and we had our prop that's called stage. And this is the stage we're sending in from the Tetris component. So we can actually import this one here in the tetris.js file. We can import our create stage function here. And we grab it from //gamehelpers, like so. And for now, we can just send it in to this one. We have the stage prop equals curly braces, create stage, and parentheses because we invoke this function here. Just checking so we're not breaking anything here. No. And we're going to change this later on because we're going to have the stage in a custom hook and a state for this one. But for now, we can just send it in so it renders something. Inside our stage component, we can remove this one, and inside the div here, we create the curly braces because we're going to use JavaScript now and map over our stage prop. So we have a row, and we also map through that row, and then we get our cell and our X value for that one. So what are we doing here? Well, we have the stage, that's the one we created. We map through that, and when we map through that stage array, we get the row, and each row is also an array that holds the cells. So we map through that row also, and we get the cell. So for each cell, we are going to render out a cell component. We can set the key to X. And our type are going to be the first value in the cell array. And that's the one we created down here. We're telling it when we initially do the render, we're telling it that this stage is clean. We don't have any Tetromino in the stage. So we're grabbing this value here, and that's a 0 that we set it to initially. Go back into your stage component. We have to close this one also. So this one should hopefully render out the stage for us. But as you can see, we didn't style it yet. So it's just a lot of cells here in one column. But we're going to fix that when we do the styling later on. All right, let's get back to our code. That's our stage. Now we have to create our Tetrominos. And we're going to keep them in a const that's called Tetrominos. And it's going to be an object. So we export const, capital letter, Tetrominos equals an object. And we're going to have different properties for these ones. First, we can create a property that's called 0, because I'm going to use this initially when we start up the application. We don't want to show a Tetromino on the stage, but you could do it some other way, of course. But I think it's nice to have it inside of this Tetrominos object. All right, so we create an object. We're going to have a property that's called shape, and the shape is also going to be an array with arrays. I noticed that there's a lot of arrays with arrays when you create games like this. So we have an array, then we have another array, and we just set it to 0. And then we have another property that's called color. And this is just going to be a string, 0, 0, 0, like that. So that's our clean cell. That's what we're using when we're not showing any Tetromino. And then we have 7 different Tetrominos. We have the I, J, L, O, S, T, and Z. So we can start by creating the I. So we create a new property that's called I, and we create a new object for that one. We have the shape property that's going to be an array. And inside of that array, we're going to have another array. And as I mentioned before, a 0 equals nothing on the grid. And we're going to use a letter where we want to show these Tetrominos. First, we have a 0. That's nothing. Then we have a string with a capital I. Then we have a 0 and a 0. Then we create another array with another 0 and another I and a 0 and a 0. And this one is just going to be a 4x4. So we can copy these ones and paste them in like that. And as you can see, this is going to be the I shape. That is the long one, the long Tetromino. That's the only one that has 4 in width. And we can make it a little cleaner here, maybe. I will not auto-format this because it will destroy this formatting I've done here. It's easier to see the Tetromino here. Otherwise, it will format it in just one line for me. And that's no good. So we have another property here also. So we have the color. And this is yet again a string, and this is just an RGB value I'm going to use in the CSS later on. So I'm setting the color for this one to 80227.230. So this is the I we have here. And I guess we can just copy and paste this one. Make sure you make a comma there. And we create a J. And the shape for the J is going to be, we can remove these last ones because it's going to be 3 by 3. So we remove the last row there also. Change these ones to J, J, J. And we're going to have a J there also. I hope you see this. Oops, it's going to be a string. I hope you see this pattern here, that this is a J. And the color for this one is going to be 3695.223. All right, then we copy this one and paste. We're going to create the L shape. And it's exactly like the J, but we change this one and put it there instead. And of course, we should have an L also as a value in these strings. And the color is going to be 223, 173, and 36. All right. We copy this one. Make sure you don't forget the comma there. And we're going to create the O shape. And this is actually just going to be 2 values in. So we have the O and O, like so. And O. So we have a 2 by 2 array there. And the color for this one is going to be 223, 217. Yeah, and also 36 for that one. All right. Then we can grab the L up here, copy it, make another comma, paste it. We have the S shape. And it's going to be a 0, an S. Don't forget that this is a string here, so don't forget the ticks here. And then we have an S and an S and a 0, and these ones are just going to be zeros. Like so. And the color is 48, 211, and 56. All right, then we paste in yet another one, and we have 2 to go. We have the T. And that shape is going to be 0, 0, 0. Then we have a T, and a T. And then we have a 0, a T, and a 0. A nice little shaped T there. And the color is 132, 61, and 198. And then we have the last one, and that's the Z. Whoa, kind of boring this, but we have to do it. Otherwise, we don't have any Tetrominos. All right, the Z. We have a Z, and a 0. Then we have a 0, a Z, and a Z. And then 0, 0, and 0. And then we just have the color for this one, and that's 227, 78, and 78. All right. So that's our Tetrominos. And we have one more thing to do, because we want to have a function that generates a random Tetromino for us. So we export const random Tetromino. And we create the function for that one. We have curly braces here. So first we create a const called Tetrominos, lowercase letters. And we create a string with capital letters IJLOSTZ. And this is, of course, the string with all our 7 Tetrominos. Then we create another const, rand Tetromino, like so. We're going to grab a random letter from this Tetrominos string, and we do that by typing Tetrominos. That's the string const. And inside of here, we do a little math.floor, math.random, times Tetrominos length, like so. And this is just a standard for generating random numbers of the length of this, in this case, the string. So we have the string length, and we're getting a random number for this one. And I misspelled this one. It should be Tetrominos. Yeah, so we have the Tetrominos string, and we're grabbing a random number for that one, and that will return one of the letters for us. And that's how we get the random Tetromino. Because now we can return from our Tetrominos, rand Tetromino. So, for example, let's say that this will give us an L here. So we have that one, and we go to our Tetrominos object, and we have an L here. And that will, of course, grab the L property for us and return this one here, the L Tetromino with the shape and the color. This is an object here, so we get that object back. And that's how we get a random Tetromino. I've typed a 0 here. It should, of course, be an O there. And save this one. All right, this was a lot, I know. And I think that's why I don't do games. But I recommend it to really go through this code and try to understand it as much as possible before moving forward. In the next video, we're going to create the styles with style component. And after that, we're actually going to start to do some heavy coding on the game. We're going to do some styling now to get this sad look out of this Tetris game. And if you're not a CSS person, you don't like to style things, you can just copy and paste the styles from the starter files into your project. But you have to import them into your component, as I'm going to show in this video, and also change your divs to the components that we're using from the styles component. I'm going to show you this soon. So let's get on with it. First of all, we're going to create the global styling. And actually, I've been kind of lazy for this one, because you can create global styles with style components, but I'm actually just going to use this index.css file that's pre-made for us with create React app, and it's imported in the index file. And that's because we're going to have a font, and it's a little bit more troublesome to import it with style components. So if we go inside the index.css file, first we're going to set our body, we're going to set our margin to 0, and then we are going to import a font. So we have a font face. And the font family is going to be called Pixel. And we have a source, src, with our URL. And we grab our font from font/pixel-lcd-7.vof. We can also set the format to vof. Like so, and we save that one. Yeah, and we will not see anything happening here right now. But that's our global styling. Then we can move up to our components, and we're going to style the Tetris component first. And what I like to do when I use style component is that I create this folder where I place all of my styling, and then I import them into the components. So inside of the components folder, create another folder that's called styles. And inside the styles folder, create a new file and call it styledcell.js. I also like to name them like this, with styled and then the component name and .js. So styledcell.js, capital S, capital C. And first we have to import styled from style components. And then we need to export our style component, because we're going to import it into the Tetris component when we created this one. So we export const styled cell and equals styled dot, and this is going to be a div. We have backticks because this is a tagged function. And this is how style components works. You have this tagged function and you can write regular CSS inside of it. And if you don't know style components, I really recommend you to read more about it at their webpage. I'm not going to go through everything with style components in this tutorial because, as I said before, this tutorial is about showing you how to build a Tetris game with React. And I assume that you know some stuff with React and style components also. Otherwise, it's not that difficult to use style components, so I think you will pick up a lot just watching me create these components. All right, and I just realized I created a styled cell now. Okay, I said Tetris component, but it's the styled cell I created now. So, well, let's create the styles for the cell component first then. Okay, we're going to have a width and set that to auto. Then we're going to set our background, and that's going to be an RGBA. And we're going to grab this from the props that we send into the cell component. So for now, I just type this out, and we go to the cell component, and I'm going to show you how this prop works. So we have a $, curly braces, and props, and an arrow function, and a props. We have one that's called color. So that's how we get our RGB value, and we set the alpha value to 0.7. This is just regular CSS. So we're going to come back to this in a second, but first we save this one and we go into the cell component, and I'm going to show you how this works with the props. So first of all, we import our styled cell. That's the one we created, and we grab it from styles/styled cell, like so. Then we're also going to need our Tetrominos. So we import our Tetrominos. If you remember, that's the one we created down here. It's an object with different Tetrominos. So we grab that from /Tetrominos. All right, so now we got everything we want in this component. We can now first change this one to our styled cell. That's the one we create here, and we import it in this component here, so we use it here. You could write a style component inside of this component, and many people do it like that, but I like to have them separated because I think this is, I like this structure of things. So you can do whatever you want, and then you don't have to do all this export and import stuff that I do here. Okay, so this styled cell is going to have a type prop, and we grab the type from type. We are sending that in here. And now we're passing that prop into our style component. And then we're going to have a color, and the color we can grab from the Tetrominos. And the type is going to be the Tetrominos. So if we, for example, have the type of L, it will grab the Tetrominos L for the color. And of course, we're also going to grab the property color, because when we created the Tetrominos, we have both a shape property and the color property. So this is the one we're grabbing here. It's the color property from the Tetrominos. All right, so for now, we change this one to, we can say an L, because we're not sending in anything to this component yet. Because, as I said, I intended to do the Tetris first, but now we do the cell here instead. And as you can see, now we're getting the color here, but it will color everything here. And that's because this cell row, you see, it take up the complete width here. So the color is there, but we haven't created a grid yet. And that's because it's showing all yellow now, because each cell is 100% width right now. All right, let's go back to the styling. We need some shadows on our Tetrominos. So this is also how it works with props that you send into your style components. You can grab them with an inline function like this. Because this is a tagged function, you can use a $ and curly brackets and use expressions inside of these ones. And by using this inline function, we can grab the props that we send into our style components. And we had one prop that is called color. So we're grabbing that one inside of here. All right. So that's our background. We also want to set our border. Yet again, we have a $sign and curly braces. We have our props. And then we're going to do a ternary operator here. We check if our props type, if that one equals to 0, that means we not have a Tetromino in this specific cell. So we don't want to have a border, so we set that one to null pixels, solid. I don't think we need solid there, but yeah, let it be there for now. Otherwise, we set it to 4 pixels, solid. All right. Then we have our border bottom color, and that is going to be on RGBA. And yet again, we have a $sign, curly braces. We have our props. And we have our props.color. And we're going to set the alpha value here to 0.1. We can actually just grab this one and copy. And paste it in 3 times. Because now we have border right color. And that one we're going to set to 1. And then we have border top color. And we set that one to 1 also. And border left color. And we set that one to 0.3. And this will give us kind of the shadow effect on the blocks. Yeah, if you don't like them, you can just play around with these and set your own shadow. And this is also what I like about style components, because you can send in props like this. We can easily modify our CSS conditionally with props. And that's really nice, actually. So what I'm doing here, I'm just using the same color value as we set in the Tetrominos object, but I'm just changing the alpha value to get different opacity on the blocks. All right, let's go to our Tetris.js file now and do it in the right order here. We are going to create 2 different style components here. We have one that's styled Tetris wrapper and one that's called style Tetris. So we have a wrapper around here and we have the Tetris also. We can actually just type them out here so we can see the structure of it. Here is going to be a styled Tetris wrapper, like so. And we close it down below there. And it will complain now because we haven't created this one yet. And then below, we're going to have the styled Tetris component. And of course, we have to move that down here. Like so. And I will explain later why we have this wrapper here. So these are the 2 style components. So let's create a new file inside of the styles folder. That's called styledtetris.js. And inside that file, inside styledtetris.js, import styled from styled components. Like so. We also need to import our background image, so we can call it bg image. And we grab that from /img bj.png, like so. Then we export const or styled Tetris wrapper. And that one is going to be a styled.div. And we have our backticks because this is a tagged function. We set our width to 100, viewport width. And our height to 100, viewport height. Yeah, this is just regular CSS now, and I'm not going to explain the CSS here either. I hope you know your CSS. Otherwise, you can pick up some things here, but I won't explain them in detail. And here we can set our background with a URL. And now we can just use our BJ image. And we do that by creating a $sign and curly braces. And inside we have our BJ image. And we can set a default color to 000. We have a background size of cover, and overflow is going to be hidden for this one. And this is also great with style components, because otherwise if you set a background image, you may have done some inline styling to get the image to show up as a background image. But here we can just import it and use it in the style component like this, so we don't have to do any inline styling on the component itself. All right, then we have our export const styled Tetris. And that's going to be a styled div also, tag function. This is going to be a flex. We align items to flex start. We set our padding to 40 pixels. And we have a margin of 0 and auto. And a max width of 900 pixels. The CSS here is not really optimized. You can try to get a better look for yourself if you want to do that. I haven't put that much time in the CSS styling. I just wanted something to work fairly good, so you could probably improve the CSS and get a better grid and stuff like that. And inside here we have our aside, and we're going to style that. And this is also great with style components, because you can nest them inside of here, just like you do in SAS, for example. So we set our width to 100%, a max width of 200 pixels. We set our display to block and padding to 0 and 20 pixels, like so. And that is going to be our style component for the style Tetris. Now we just have to import it up in the component. So we can import our styled Tetris wrapper and our styled Tetris. And we grab them from .styles/styled Tetris. And no, it shouldn't complain here. No. All right. And as you can see, we are gradually changing this one to something else. So we see the space here now, and we see that the cells are just, these tiny bits now. All right, then we can create another style inside our styles folder. That's called styleStage.js. And we create the style first. So we import styled from style components. Then we export const styled stage. And it's equal to styled div. And we have backticks because it's a tagged function. And we're going to display a grid for this one. We have our grid template rows. It's going to repeat. And we're grabbing from props. Or props.height, a comma. And then we're going to do some CSS calculation here. We have 25 viewport width, and we divide it with, we have $sign and curly braces, because now we're going to have another inline function to grab our props. And we grab the props.width, and this is going to do some nice little calculation for us to make the grid look nice. And we are doing this to keep the aspect ratio of the grid cells. Then we have our grid template columns. That's also going to repeat. And from our props, yet again, we grab our props.width, and it's going to be one fragment. And of course, that one should be there. Like so. These calculations is because we want to keep the aspect ratio of our cells. We want them to be perfect squares all the time. And this is actually kind of tricky to do. So yeah, I've got it to work, fairly responsive, but not 100%. So if you come up with a better idea, feel free to change it to whatever you want. We want to have a grid gap of 1 pixel, and the border going to be 2 pixels, solid, and we can set it to 333. We have a width of 100%. And a max width of 25 viewport width. And a background of, say, 111. All right. So that's our styled stage. We just have to import it into the stage component. So make sure you're inside the stage component. And import styled stage from /styles/styled stage. All right, and then we rename this one to our styled stage. And we close it with the same. And we're going to send some props inside of this because we had a width, and that one we're grabbing from. We are sending in the stage as props to this one. So if we grab the stage and the first row and the length, we know the width of our grid, and the height, we just grab the stage length like so, and that will give us the height from our multi-dimensional array. All right, we save this one and see what we've got. And as you can see, we have something here. So we're slowly getting there. We can actually now also go back into the cell component, and we can remove the text here. We don't need that one. And that's why we can just self-close it like this. And that will get us our grid. And here you can also see the shadows that we created in the cell component. And it works fairly responsive. What have we got left to do? We're going to style our display and our start button. Inside our styles folder, create a new file, styled display.js, and import styled from styled components. And we export const styled display, and it equals a styled div, and yet again backticks. Box sizing to border box. We display flex. We align items to center. Why I'm using flexbox is to align the text in the different displays. We have a margin of 0, 0, 20 pixels and 0. We have a padding of 20 pixels. We have a border of 4 pixels, solid, and a triple 3. We have a min height of 30 pixels. We have a width of 100%, a border radius of 20 pixels, and the color, and that one we're grabbing from props. So yet again, we have a $sign and color braces. We have our props, and we do a ternary operator because we are using the same display component when we display game over as we display the score and rows and things like that. So we have a prop that's called game over. And if it's game over, we set the text to red. Otherwise, we set it to some grayish. And we set the background to black. We have a font family of pixel. That's the one we imported in the global CSS file. And we can set it to some fallback fonts here. And the font size of 0.8 rem, like so. And then we just have to import and use it in our display component. So we import our styled display from /styles/style display. And then we change this div to our styled display component. And we also had our prop that's called game over. So we send that one in like so. And let's see what we've got. And there's some nice displays, and we have this retro font inside of them, and that's good. We just have to style our start button, and then I think we'll be good to go to do some heavy coding on this game. So inside of styles, create a new file and call it styled startButton.js. Import styled from styled components. Woo! Getting boring. But we have to do this. So we export a const and styled start button. And we have a styled button. double backticks, and inside we write our CSS. We have our box sizing, and we set that one to border box. We have a margin of 0, 0, 20 pixels, and 0. We have a padding of 20 pixels, a min height of 30 pixels, a width of 100%, and a border radius of 20 pixels. A border, we set that one to none. We have a color of white, a background of a 333. We have a font family of pixel and some fallback fonts. We have a font size of 1 rem, an outline of none, because we don't want to display that ugly outline when we press the button. We set the cursor to pointer also. And we save that one, and inside our start button, we are going to import this one. So we import styled start button from /styles/styled start button. And of course, we change this one to styled start button. We are also going to have an on-click handler on this one, so we can type it in now. So we have the on-click, and it's going to be a callback. All right. So that's the start button. And it's showing nicely. But nothing is happening now because we don't have that callback created yet. But we have something that looks like a Tetris. We're just going to remove this yellow one from our cell, because the type is going to be the type. And here we also change that one to type, because that was only to show you what we were doing here. And as you can see now, we have our grid here instead. And that's nice, because that's our playing field and everything's set up for us, so we can start coding the real game here. And we'll start with that in the next video, so see you then. Okay, we got our stage, our displays, and our start button, and it's time to code some logic for this game. And how is it going to work? Yeah, well, we're going to have this stage, of course, with the cells here, and we're going to have a player. And we're going to use React hooks to create this game. And two big advantages with hooks is that you can abstract them, and you can reuse them, and compose things together, and that's really great. And for this game, we're going to create 3 own custom hooks. And that's the useStage, usePlayer, useGameStatus, and the useInterval is the one that Dan created for us. And the reason that I created these custom hooks is that I want to kind of separate out the logic for different things. So we have all the logic for the player in the usePlayer hook, and we have all the logic for the stage in the useStage hook. And we also have the useGameStatus that is going to have, mostly the display logic that we're going to show, like the scores and things like that, and how many rows we cleared. So that is how we're going to divide up the code. And we have the Tetris component. That's going to be our main component. As I said before, that's the heart of our application. And as we're creating a game, we're going to have some kind of game loop. And as I also said before, we're going to use an interval for this one, and not using, maybe the more sophisticated way where you get animation frames and stuff like that. So we have this grid here that is represented by the array, and we can actually console log this one out so we can see what we have in our array. So inside of here somewhere, we can console log create stage, like so. And I'm just going to show the console here. And as you can see, we have an array with 20 rows in it. And each row has 12 cells. And as you can see here, we have a 0, and that means that this cell is clear. We don't have a Tetrominos in this cell. And it's also set to clear. As we can see now, we just have a clean stage here. So everyone here is clear. And that means that we don't have any Tetrominos merge into our stage. Because when we collide with something, we're going to change this one to merge. And in the next render, we're going to keep every cell that has merged here. And that's the way we keep the Tetrominos that has collided. I think it will get much more clearer when we actually create the Tetromino and how our game loop works, because the game loop are going to do a couple of things for us. The first thing we have to do in our game loop is that we clear the stage, and then we check for any merged cells here, and we don't clear the merged ones, so they are going to stay in the stage. They're going to stay in the array for our stage. And then we're going to check the position of our Tetromino, and if it hasn't collided, we are just going to set it to clear again, and that means for the next render, it's going to be wiped out, and it's going to move, and that's the way we get the illusion of movement here. Or maybe it's not an illusion, it is a movement, but the Tetromino that hasn't collided is getting cleared on every render. But if we have set this to merge, it's going to stay in the stage. And then we do this over and over again with our interval, and that's the way we get the movement for our Tetromino. So that's the short, very compact version of how this game loop is going to work. And we also kind of have to look into the future, because we are going to check the collision before we actually move the player. So when we make a move, if it drops or if you move it with the arrows on your keyboard, we first check the collision before we make the move. And if it collides, we don't make the move, because then we know that it has collided. We always check the game field, the stage, one step ahead before we make the move. And that is also going to be much more clear when we actually do this coding. I just wanted to explain it shortly for you, so you have a rough idea of how this is going to work. All right, so let's get back to our code. We can start in our hooks directory, in our hooks folder, and inside of that folder we create two new files. We create one that is called usePlayer.js and one that is called useStage.js. And as I said, I always name my files as the component, or in this case, the hook itself. And in React, you always name your custom hooks with use before the actual name. So in this case, it's useStage and usePlayer. So we can start off in the usePlayer.js file. So make sure you're inside of that file. And we import, and we're not going to need React for this one. We just need the useState from React, because this is not a React component. So we're just importing the useState. Then we can import our random Tetromino function. And we grab that from //Tetrominos. Then we export const, and we have our usePlayer. As I said, it's important to have use before, otherwise React won't know that this is a custom hook. And we have an arrow function, curly braces. And we're going to create a state for this one. And that's the only thing we're going to do in this video. Then we're going to build more up on these files in the next videos. We're going to create a state now with a hook that's called useState that we imported up here. And useState will return an array with two items in it for us. And that's where we can use ES6 destructuring to grab these two values. So we have a const, and we have an array that we want to destructure. And we can call it a player, and we have the set player. And we use state. And this is the way that useState works. As I said, we get two values back. We got the actual state here, and then we have the setter for this state. You can call them whatever you want. They don't need to be player or set player. And this is just two values that we destructure out here. So this line here is actually short for all of this. We have a const with player state, maybe, and we use state. And then we have our player, and we grab player state and the first value in the array. Then we have our set player, and then we have our player state and the second value in that array. But by using ES6 destructuring, we can make it in one row here, and that's very, very convenient, and that's the way you should do it when you use state. So get rid of this. We are also going to set an initial state for a player. And you can actually send in your initial state to the useState when you create the state with it. We're going to have an object, so we have curly braces. And inside we're going to have a property that's called pos, that's the position for our player. We're going to have an X value and we set that to 0, and an Y value, we set that to 0 also. And then we have our Tetromino. And that's going to be one of them we created down here that we're always going to keep in this state for the player. And for now, we can actually just set the random Tetromino. So we call that function, and we're going to grab the shape from the Tetromino. And if you remember, we had one shape property and one color property. So this is the one we're grabbing here. That's the shape of our Tetromino. 0 equals nothing, and the letter inside of here equals the cells that are occupied in our Tetromino. And I choose to have the letter of the actual Tetromino here. You could actually have the same letter for every one of them. It doesn't matter, because we're just going to check if it's not 0 when we render the Tetromino to the stage. All right, so we grab a random Tetromino and the shape of that one and put it in our state for the player. And then we're going to have a property that's called collided, and we set that to false. So that's our initial state for the player. And then we're actually just going to return the player, because we're going to import this custom hook into our Tetris component, and then we're going to need the player inside of the Tetris component. I'm going to show you this in a second. For now, this is it for the usePlayer. We're going to return to this file, and we can now move on to our useStage hook and do almost the same for that one. So we import useState from React. So we import create stage from //gamehelpers. All right. And then we create our custom hook. So we export const, and we're going to call it useStage. And it's an arrow function, curly braces. And we create the state for this one also. So we call it stage and set stage. And we call the useStage hook. And inside of this, we're actually going to give it the initial stage. And we can just call the create stage inside of here, and it will generate the initial stage for us, the clean board for our game as we have here. So that's our state for the stage. And we're going to return. We're going to need both the stage and the set stage for this one. So we return them. And I can see that I typed useStage here. It should of course be useState, like so. So we save this one. And then we're going to do a little bit of coding in our Tetris component also. So make sure you're inside your tetris.js file. We can actually remove the create stage for this one now. We just had it before. We're not going to need that one because we're creating the stage in our useStage hook now. So remove this one. And we can actually make a little comment here. This is a style components. And then we're going to have our custom hooks. So we import usePlayer from //hooks and usePlayer. And then we also import our useStage from //hooks useStage. All right, and we already have imported the components. We are going to use some state in this component also. So we have to import useState up here. All right. So we're both importing React and useState. And now we can remove this console log. But it would be nice to have a console log here that tells us if it re-renders. So we can create that one console log re-render. It's always nice to have. And then we're going to create two states now actually, because we're not going to use them right now, but we can create them as we're already in this component. We're going to have one that's called drop time and one that's called game over. And the drop time is the actual speed that we're going to modify depending on which level we're on. And then the game over is simply going to tell us if the game is over or not. So we're keeping true or false in a state for that one. So we create the new state that's called drop time and set drop time. We have useState, and for this one we can just initialize it with null. And we have our game over and set game over and our useState. And we set that one to false because it's not game over when we start. And then we're going to use our custom hooks. And if you remember from our player, we exported our player. And that means that we can grab that one with the structure here, const player, and use player like so. And we also have our stage. And for that one, we exported 2 different values in an array. So we can destructure them out also. So we have our stage and our set stage. We run our custom hook called useStage. And we send in the player to this one. We're not using the player in this custom hook yet, but we are going to need our player in this one. So we're going to modify this to use the player later. So that's why we can send it in already now, because we have the player here. So we send that one in. Okay. And then we can remove this one because we're not needing that function now. We already have our stage in our variable called stage that we get from useStage. So we use that one instead here. And we can actually also use this game over variable here. Because when the game is over, we're going to show a display that says it's over. So somewhere in the aside here, we create curly braces. We check our game over variable. If that one is true, we're going to show a display component with a prop of game over. We're sending that one into the display component because if you remember, we're changing the color of the text to red if it's game over. So we just simply send in the game over variable and we have the text that equals to game over. And we self-close the component there. This is a ternary operator. So if the game is not over, we're simply going to display everything of this. Like so. So if we have a game over, we just display this one that says game over. We don't display the score, the rows, and the level. And if the game is not over, we are displaying all of these. So we save the file and it seems to be working. We didn't break anything in the game and it's just complaining here because we're not using these values yet, but that's fine. In the next video, we are going to create the player movement with the keys on the keyboard. And we're going to do the stage update. We're actually not seeing any Tetrominos now, but we will see it in the next video, hopefully. Okay, let's create the movement for the player and also the stage update so we can see the changes take place on our stage here. First, we're going to be working in the Tetris.js file, the Tetris component, and I'm actually going to take back some code we deleted in the last video. We are going to use the create stage function in this one also. So import it again. Sorry for that. We import create stage from ../gamehelpers. We're going to need this one. When we restart the game, we need to create a clean stage for that one. So we're going to need a few functions now because we're going to create the movement for the player. So down below here, somewhere below the console log re-render, we are going to need a function that's called movePlayer. And it's going to take in a direction as a parameter. For now, we just leave it empty. Then we're going to need a function that's called startGame. We leave it empty for now. We have another one that we call drop. And we leave that one empty. And we have another one that's called drop player. Yeah, and that may seem odd now that we have 2 similar functions here, but it will get clear to you when we have more code in this component, and I'll explain why then. And the last one for now is a function that's called move. And we're going to destructure out the key code for this one. This is going to be the callback function when we press the keys on the keyboard. All right, we're going to fill them with code in a second, but first I'm going to explain this style Tetris wrapper for you. So we created this one with a width and height of the complete window here, and that's because we need some way to take our key inputs, and this one, the wrapper div here, is going to be responsible for that. So it's going to have a few props. We need to set the roll to button, otherwise it won't respond to the key press, and we need to have a tab index that equals to 0, and we have an on key down, and we're going to call our function that's called move for that one and send in the event. So that's why we have this style Tetris wrapper. It's on kind of, you don't see the div here, but it will cover the complete screen here. And that's why when we, for example, click here, it will register the key presses for us. If we didn't have that one, or for example, just put the key press on this one, you have to click on this to get the key presses to register. Let's go to our callback function that's called move. That's the one we call here. First of all, we're going to check that the game isn't game over, because then we don't want to register any key press. So if parenthesis and not game over, then we can do something here. And then we check again if our key code, we destructure that one out from our event, because on our event, we have a property that's called key code. And if we destructure it here, we don't have to type e.keycode. A little win here, because that's not too long to write an e, but yeah. And we're checking if the key code equals to 37, and that's the key code for the left arrow on the keyboard. Then we're going to move the player. We call our move player with the -1, because we're moving to the left. That's why it's -1. If our key code equals 39, that's the right arrow on the keyboard, we're going to move the player to the right, and that's why we have a 1 here. So left equals -1 because we're moving -1 on the x-axis, and 1 equals right because we're moving 1 step on the x-axis. And then we have another else if. If the key code equals to 40, that's the down arrow on our keyboard, we drop the player because we're pressing down, so we want it to go down. So that's our move function. And in our drop player function, for now, we're just going to call the drop. So we're just calling this one. We're going to have another little special case inside of this later on, so I'll explain that then. Then we have our drop function, and we're going to create a function in our usePlayer hook that's called updatePlayerPos. And yeah, it will do what it says. It will update the player position. UpdatePlayerPos. And we're going to give it an object with the x value of 0 and the y value of 1 because we're dropping now. And I can see that I'm in the wrong function here. So just copy and paste that one inside. It should be in the drop function. So as we're dropping here, we're going to increase the y value of 1 and make the player Tetromino go down. And we set the collider to false. All right, it will complain because we haven't created this function yet. And in the start game function, we can just make a little comment here, reset everything. And we set the stage to create stage. We call our function to create a new stage, and we reset the player. And that's also a function that's going to be in the usePlayer hook. And the start game is a callback function also that we're going to have on our start button. So we can set an on-click handler and call the start game function. So what we'll do when we press the start game button, we will reset the stage and we will also reset the player. And then we have our move player function. And that one is going to take care of the left and right movement. So we call the updatePlayerPos. And we give it the x value of direction and the y value of 0. Because now we're just moving left and right, and we're giving it a value here, -1 or 1. All right, we save that file, and it will break now, of course, because we haven't created these ones yet. So we have to create the updatePlayerPos function and the resetPlayer function, and we're going to place them in our usePlayer custom hook. And that means that when we call our usePlayer function here, we also want to get the updatePlayerPos and the resetPlayer from that custom hook. All right, so let's move into our usePlayer hook. So make sure you're in the usePlayer.js file. And we're going to continue to write some code here. We're going to create these two functions here. So we have our updatePlayerPos, and it's going to be a function that takes in an object. And we can destructure out x, y, and collided from that one. And we create an arrow function, curly braces. And inside of here, we're going to set the state, because now we're moving the player, so we can set the player state here. So we call setPlayer. That's the one up here. And we do that with an update function. If we do that, we get the previous state here. And we have to have a parenthesis here, because we just can't give it the object, because it will think that these curly braces are for the block. And that's why we have the parenthesis here. We spread our previous state. We set our pos to the new one. We have an x property. So we set that one to our prev.pos.x plus equals x. Then we set our y value, prev.pos.y, and plus equals y. So we're adding the values to our state here. And then we set our collided property. Like so. So that's the update player position. We're just setting the state with the new x and y values here and our collided value. All right, then we need one for reset player. So we create the const reset player. And for this one, we're actually going to need a hook that's called useCallback. And that's because otherwise our game loop will go into an infinity loop. We won't see it now because we haven't created one yet in our useStage hook where we're going to use this function. But trust me, we need to have the useCallback here. Otherwise, we will be in a mess with an infinity loop. So we use callback and give it an inline function here. It is going to be dependent on nothing because we just create this once. So we set the player, and in this case we're resetting everything, so we won't need to have this update the function here and give it the previous state. We can just set the state from scratch. So we have our position or pos, our x property, we set that to our stage width, and we divide it by 2. I subtract 2 also to get it kind of in the middle, because this one will position the Tetromino in the stage, so this one will give it kind of in the middle. And we have our y property, we set that one to 0 because we want our Tetromino to be at the top when we reset the player. And we have our Tetromino, and we will give it a random Tetromino and grab the shape. So each time we call this, we will get the random Tetromino, and this is the way that the Tetrominos change randomly. And we set collided to false. Like so. We also have to import the useCallback up here. And useCallback is a standard React hook. And the last thing we have to do for now is also return or update player position, or update player pos, and or reset player. And this should be it now. So it's still working, but nothing happens here because we're not drawing anything to the stage now. And that's what we're going to be doing now. So let's go into our useStage.js file, or useStage custom hook. And this one is going to be a little maybe complicated, but I hope we will get through it. And that's the thing with game making, because as I said, I'm not a game maker, so some stuff can be hard to understand when you're not a game maker. But even if you don't understand everything that's game specific, I hope you will learn some stuff in React. Okay, so let's continue in this one. We're going to take in our player and reset player as our parameters for this one. So add these ones up here. Then we're going to use the hook that's called useEffect. And that one is for creating side effects with React, and it's kind of a replacement for the lifecycle methods in the class components. I won't go into detail with every hook here, so you have to look up that yourself if you don't know how useEffect works and what it's for. They have an excellent text on the React homepage where you can read about all the hooks. All right, so we create our useEffect. And that one is going to have an inline arrow function where we're going to create everything for our effect. And this is the dependency array. For now, we can just leave it empty. We create another function inside of here that's called updateStage. We're going to give it the prev stage, the previous stage. And below here, we're going to set the state of the stage with this function. So we have the stage state here, and we set it with the set stage. So set stage. And then we have our update function. So we grab the previous stage state. It's easy to be confused here with stage and state. It's almost the same saying that. So we call our update stage with our previous state. And you can also see that we're placing this function inside of the useEffect. And by doing this, we don't have to specify it as a dependency here, so we can have it inside of this effect. All right, and now we have to do some things here, because when we update the stage, we first have to flush the stage. We have to kind of clear it from the previous render. So we create a const with a new stage. We take our previous stage, or prev stage, and we map through it. So we get our row, and we have an inline function here. And we make another map on our row, because this is a multi-dimensional array, so we have to do two maps here. It will probably be a little bit faster if we do this with just for loops, but I think we will be fine here using map. But if you care a lot about performance, you shouldn't use map. I think in a game like this, you should use the for loop, because that will be faster than the map. All right, so we have our row, we map over our row, and then we get our cell. And we're going to return a new cell value. And here we're going to make use of the one I talked about here, where we create the stage, where we set it to clear or merged. So I'll show you that now. We create a turner operator here. We have our cell value. We check the value in our cell array. And I will go back to this again to make it as clear as I can. It's this value here we're grabbing. So we simply check if that one is set to clear. Clear. Then we are going to return an empty cell. So we return an array with a 0 and clear. Otherwise, we are just going to return the cell. And this is what I've been talking about before. Because if we haven't marked our cell to merged, then we just swipe it out, we just clear it, and we return a fresh, clear cell here. Otherwise, we return the cell as it is, and it will stay in the stage. So that's the way we know what cells have collided Tetrominos in them or not. So we have flushed the stage here, then draw the Tetromino. So we flush the stage, remove everything that shouldn't be there, and then we draw the new stage for this render. And we can do that by loop through our Tetromino. And we have our Tetromino in our player. If we check our usePlayer, we created the state here. So we have the Tetromino here. It's in the object for the player. And in our Tetris, we are sending in the player to the useStage. And we're getting it here. So that's why we can access the player in our useStage custom hook. So we have our player and the Tetromino property. For each, we're not going to return a new one here. We're just going to simply loop through it. We have a row and we have a y value. Curly braces. Then we're going to map through a row, because this one is also a multidimensional array. So it's unfortunately a lot of loops here. when doing this. We have our value and our x value for that one. And we have another inline function. It may be a lot to grasp now when you're just typing it in like this. So I suggest again you stop and just try to really understand what we're doing here. Because now we're looping through our Tetromino. And now we're going to check which cells in the Tetromino that are occupied. And that way we know the shape of the Tetromino. We have our value here for our Tetromino, for our cell in the Tetromino. So we can check if the value isn't 0, then we know that we're on a cell that makes up the shape of this Tetromino. And then we also know how we can position the Tetromino on the stage. We have our new stage up here that we flushed. It's a fresh stage that we can use to draw our Tetromino. So we have our new stage. And yet again, this is a multi-dimensional array. So we have to set the y and x value for this one. First, we have our rows, that's our y value. So we have the y value plus player pos.y. Then we have our x value plus player pos.x. This will give us the coordinates on the stage. So we are going to set these ones to the value. And the value here, remember that it's the Tetromino that we're looping through, so we get the value of the Tetromino. And in this case, it's going to be, one of these values here. Let's go back to our useStage. So that's our value. And then we're going to do backticks here, 2 of them, and inside we have a $, curly braces, because we're going to check with a ternary operator if our player is collided. Then we set this one to merged. Otherwise, we set it to clear. And this is yet again how we know that we should clear this Tetromino in the next render. If we set it to merge, we know it has collided. And this one, when we flush the stage before we do this, it will be set to merged. And that way we know that we should keep it in the stage because it has collided. Otherwise, it's set to clear, and then we can just delete it in the next render before we do anything else. All right, this is beginning to be a long video. Sorry for that, but we have to do this. And inside our function here, make sure you're in the right scope here. Inside of the update stage function, we are returning the new stage for now because we're not checking any collisions yet. We're going to return to this one. And as you can see here, when I auto-formatted this one, it has filled in this itself. These are the dependencies that we need for this useEffect. So we have the player.collided, the player.pos.x, the player.pos.y, and player.tetromino. We're using them inside of this useEffect, and that's why we have to specify them as dependencies here. And we are going to use the reset player that we wrapped in our useCallback later. So that's why we have wrapped it, because we're going to add it as a dependency to this one. And it's this useEffect that will go into an infinity loop if we don't wrap it in a useCallback. All right, save this one. And as you can see, we have a Tetromino here now, and that's great. And if we reload this one, we get a different Tetromino because we have randomized them, and that's working great. And is this working? No. Okay, let's check that out. In our Tetris, all right, I see here, it shouldn't be on click. It should be callback. Because if we look in our start button, we have the prop here that's called callback. So make sure you're in the Tetris component and change this one to callback. And I bet it will work now. And it does. And I think I saw a little bug there. Yeah. It disappears, and I think it's probably when we get the same Tetromino as before, and I think that is if we go into the useStage custom hook, we have these dependencies here. So when we get the exact same Tetromino, it won't re-render because this one is dependent of the collider, the position X, the position Y, and the Tetromino. So they are going to be the exact same in the next render if we get the same Tetromino, and that's no good. I think we can just change the dependency to player and save this one. Make sure you reload it. It's working great now. I don't think this will give us any trouble in the future. So I haven't seen this bug actually before. I think I had gone through everything, but yeah, that's the thing with code. You always get surprised. I think it will be fine to have the player there. Otherwise, we'll change it later. And I also saw some little other stuff here we have to adjust, because when you start the game, you don't want this one to show up here before we have pushed the start button. And that's why I created in this file, Tetrominos, I created this 0 here with just a blank little cell here. And that's the one we're going to use for this now. So if we go back into our useStage, now into our usePlayer, you can see that we are just rendering a random Tetromino here, and that's not good. If we import our Tetrominos also here, then we can just grab the Tetromino and we grab the first one in the array, Tetrominos, and we save it. And as you can see now, the stage is blank here, and that's good. And if we push the start, it will generate a random Tetromino for us to start with. And of course, also we have created the movement for this one. So if you press left and right and the down button, we can actually move the Tetromino now. And as you can see, we have not done any collision detection yet, so it will screw up here. But that's fine for now. We will fix that later. But at least the controls are working, and that's also great. So we have something here now. We are getting somewhere, and we will continue this one in the next video. It's time to create some collision detection now for our game, because now it isn't working here. We can move outside the play field, and it looks kind of screwed up here, and that's not what we want. So let's go back into our code. And we're going to be working in the gamehelpers.js file for now. That's where we're going to place the collision detection function. It made sense for me to place it in that file, but if you feel that you want to place it somewhere else, you can do that, of course. But for this tutorial, I'm going to create it here, so make sure you're in the gamehelpers.js file. And we have to think about a few things before we create this function. One of them is that it's probably better to use for loops, because it will be at least a little bit faster than to use, for example, map or for each. Because we are going to loop through our Tetromino here again, and we're going to have 2 loops for this one also. So if we use, for example, for each, we can't break out of that one. And that's the downside for us, because we want to break out of the loop as soon as we collide with anything. So feel free if you want to experiment with this and try different ways of doing it. I'm going to use for loops, so we can start by creating our function now. We need to export this one because we're using it in the components. So we need to have an export const, and we call it check collision. We give it a player, the stage, and we give it an object where we can destructure out the move X and the move Y. So what I'm doing here is that I rename the X and Y to move X and to move Y. And that's because I'm going to use Y and X in my loops. So I want to have a different name for these parameters here. And it's an arrow function, and we have curly braces. So we're going to loop through our Tetromino in this one. So we have a for loop, let Y equals 0, and Y should be less than player.tetromino.length. And then we just have the Y plus equals 1 for each iteration. And then inside of here, we have another loop. Let X equals 0, and X should be less than player.tetromino. And we can grab the Y value dot length. And then we have the x plus equals 1. So we add 1 to this one for each iteration also. And we could, of course, just say 0 here, because it doesn't matter which row we are checking the length of, because the rows are the same length. All right? So what do we have to do here now? First of all, this is the Tetromino we're looping through, and we first have to check that we're actually on a Tetromino cell, and the 0 don't make up the shape of the actual Tetromino. So we have to check that the cell isn't 0. So we can make some comments here. 1, check that we're on an actual Tetromino cell, like so. And then we create an if statement, and we check if player.tetromino. And now we're grabbing our y value and our x value from our loops, and they shouldn't equal 0. All right, so that way we know that we're actually on a cell that make up the shape for the Tetromino, and we should check that cell if it collides with anything. So what collisions do we have to check? We make a little comment here again. We need to check that our movement is inside of the game area's height, that we're not moving the Tetromino outside of the bottom of the stage. So we can just make a comment, check that our move is inside the game area's height, and we can just set y in parentheses. And maybe also we shouldn't go through the bottom of the play area. All right, and we can actually specify the other things we're going to check before we create them. So down below here, create number 3. Then we need to check that our Tetromino isn't moving outside of the game area's width. Check that our move is inside the game area's width. And that's an X. And then below here, we have the 4th thing we're going to check. And that is, we're going to check that the cell isn't set to clear, because this function will return true or false. If it returns true, we have obviously collided with something. Otherwise, it's false and we haven't collided with something. So if the cell is set to clear, then we know that we're not colliding with anything, and it will return false. Check that the cell we're moving to isn't set to clear, because if it is clear, we're not colliding. All right, so that's our things we have to check here. We're going to do this with a chained short circuit. Whoa, that was hard for me to say, as I'm not natively speaking English. And you probably can hear that also, but you have to live with it. So if not stage, and we grab the y value plus player.pos.y plus our move y. We're looking into the future here, you can almost say like that, because we're checking here if the position that we intend to move to is colliding. So here we're simply checking that our stage's y value actually has a value in it. If it doesn't have that, we know that we're outside the bottom of the stage. And this will also return true, because we're setting this to not with this exclamation mark. So if it not find anything here in this stage row, it will return true, and we know that we're colliding with something. And as I said, we do a short circuit here. So we do an OR. I actually don't know what these signs are called in English. It's the sign for OR in a short circuit. Okay, then we need to check that our move is inside the game area's width. So we have the exclamation mark. We're checking that not stage. Y plus player.pos.y plus move y. And then we need to check the actual cell here. So we check the x plus player.pos.x plus move x. And yeah, it is complaining here because we, of course, need an if statement here also. So wrap this in an if statement and return true. And we go back to this one. We create another OR. And we're going to do our 4th check here. Okay, the 4th one we're going to check. I misspelled this. Check. We are going to check if this cell is not set to clear. And we can do that by typing stage. And then we do the same thing here. Y plus player.pos y plus move y. And then we have the cell. So we have x plus player pos.x plus move x. And then it's the second one in this array that we have to check. So we type in a 1 here, and we check that it isn't clear. Like so. And this one should, of course, be a capital Y. So there you have it. That's everything we need for our kind of simple collision detection. I actually almost copy and paste this code from the method tutorial, because I think this is a very simple and clever way to check the collision. Because with this collision detection, we can detect if we're outside the stage and also if we collide with any of the Tetrominos, because we're looping through the Tetromino that we have in play and check if any of the cells inside of that Tetromino collide with any of the cells in the playfield. And that's how this function can check for everything that we want. If we go outside the stage and also if we collide with another Tetromino that's merged to the stage. So we save it and we see that we didn't break anything and we didn't do that, and that's good. We have to go inside our useStage hook and add a little collision detection here, because when we have the new stage here with the new updated position, we then check if we collided, like so. So we can do a little if statement here. If player.collided, then we just reset the player, like so. And it will need a new dependency here, so we can add reset player. Because if we collide, we just reset the player, we move the player up to the 0y position, and the other one will stay in place where we collided, because we merge it into the stage here. The last thing we have to do here now is to go into our Tetris component and actually use our check collision function. First, we have to import it from the game helpers. So we have our check collision, import it there. And we have to check the collision when we move the player and when the player drops. So inside our move player, we create an if statement. And if we don't collide, we send in the player, the stage, and the intended position we want to move to. So we have an x value of direction, and we have the y set to 0, because this move player function is responsible for moving the player left and right. So yeah, I probably should have named it something else. Yeah, I realized that. So you can change it to a more descriptive name if you want to do that. Then we can move this one inside of the if statement. And this means that if we're not colliding with anything, we actually do the move. Otherwise, we don't do anything here. So we save it, and we can see if it works. We shouldn't be able to go outside the playfield to the left and to the right. And we can't, and that's great. So it will stop the Tetromino there, because we're colliding with the sides of the stage. Then we have to check for collision when we drop the player. So inside of the drop function, we do almost the same here. We check if not, check collision. We give it the player, the stage, and the intended move. So we have the x value, in this case it's 0, and it's the y value that we're going to give a 1, because we're moving one step down each at a time. And we can move this one up here inside of the if statement. In this case, we're going to have an else also. In this case, as we're dropping, we know that if we collide on something when we drop, we also need to set the collided property to true in the player. And that's because if we collide with something when we drop, we know that this Tetromino should be merged to the stage, because it can't drop anymore. So we need to merge it into the stage. So we update player pos. We give it an x value of 0 and a y value of 0. We're not moving anymore. We're just setting the collided to true. We can also, inside of this else block, create something when the game is over, because if we're colliding and the player.pos.y is less than 1, we know that we're colliding up here somewhere, and the game should be set to game over. So we can console log game over. And then we're going to set game over to true and set drop time to null, because we're not dropping anymore, so we set that to null. And also up here in the start game function, we can set game over to false, because we're starting a new game here, so it shouldn't be set to true. All right, we save it and see what we've got. We're checking here and it's still working with a collision on the sides. And if we go down here, it should merge into that position in the stage. And it does, so that's great. And we can see if it will go into game over mode here when we're colliding at the top. And it does also, and that's really, really sweet. But now we have a kind of half-working game. It's not dropping because we haven't created the interval, and we can't rotate the player. So that's what we're going to do in the next videos. In this video, we're going to create the rotation for the player, and we're mostly going to be in the usePlayer custom hook. So make sure you're in the usePlayer custom hook. We're going to create 2 new functions in this one. So just below our state here, we can create one that's called rotate. This one is going to receive a matrix and a direction. So the matrix is actually going to be our Tetrominos, so you can name it to that also if you want. And of course, we're going to have an equal sign and an arrow here. Then we're going to have another function that's called player rotate. And we could actually do them in one function, but I wanted to separate them out because the rotate here actually do the rotation, and the player rotate are going to do some other things also, because we need to check the collision here when we rotate the Tetromino. That's why I separate them into 2 functions. So we have the const player rotate equals, it is going to take in the stage and direction, and we create an arrow function. And as I said before, you can of course create regular functions if you want. It's just me that, I like to create arrow functions instead. But if it makes more sense for you to create a regular function, you can do that also. It doesn't matter here. Okay, so first we create a rotate function, and that's the one that's going to take in the Tetromino and the direction. And we want to rotate the Tetromino. And how can we rotate the Tetromino? Yeah, first of all, we can make all the rows to become columns instead. So we kind of shift them in the array. And that way, all the rows are going to be columns instead. And then if we reverse all of the values in the rows, we get the rotation. So that is how this is going to work. So first, make the rows to become cols. And we can call it this transpose. Okay, we create a new const. We can call it rotated tetro. All right. So we take our matrix, we map through that one. We're not going to use the actual value in this loop, but we need the index. Then we map through the matrix again. And we have the column. And we return the col and the index. And this one will make all the rows in the array to become columns. So that's the first step in rotating. Then we need to reverse each row to get a rotated matrix, or a Tetromino in this case. And this one we have to separate into 2 things, because it depends on which direction we are moving, how we do this. If we move with a direction of a value that's bigger than 0, we know that we're moving kind of clockwise. Then we need to reverse all of the rows to get the rotation right. Otherwise, if we move in the other direction, if it's, for example, -1, it's less than 0, then we just reverse the complete matrix, or in this case, the rotated tetro, as we called it. I know that this can seem a little bit too much, and I think this is one of the things, again, with game making, you do this stuff all the time when you rotate things. I actually had to think about this twice or 3 or 4 times before I got it myself. And he explained it quite good in the Math Methods video on how he rotate things. I don't do it exactly the same here in this function, but the principle is the same. We have transposed our array or matrix or Tetromino, and we have converted all our rows into columns, and we save them in the rotated tetro. Then we can check if the direction is bigger than 0. We return our rotated tetro that we're going to map, and we have the row, and all of the rows are going to be reversed for this one. So we use the reverse function on this row, and that's a built-in function in JavaScript. Otherwise, we're moving in the other direction, so we can just return the rotated tetro dot reverse. Okay, now we can create our player rotate, where we're also going to do some collision detection when we rotate the player. And I'm going to show you why in a second. But first, as always, we don't want to mutate or state or anything, so we create a copy of our player. We can call it cloned player. We cannot do a shallow copy here, so we need to make kind of a deep clone, and you can do that with json.parse and json.stringify player. So now we get a complete copy, a complete clone of our player. And that's good. We don't have to work with a player that's in the state, because we shouldn't mutate the state. Then we take our cloned player and grab the Tetromino from that one. And we use our rotate function. And we rotate the cloned player.tetromino. And we give it the direction also. And this will rotate the player, and we can set the player to the cloned player. We also need to export our functions here, or actually it's just the player rotate we need to export. We will get back to this in a second, but first we have to actually create the rotation in the Tetris component. First of all, we need to add the player rotate here, so we get it inside of our Tetris component. From the usePlayer, we're also returning this one. Then below here in our move function, where we check the key code on what key is pressed and call a function, we also need to add another else if here. So if the key code equals to 38, that's the up arrow on the keyboard. We call player rotate, give it the stage and the 1, because we are going to need a stage when we do the collision detection in a minute. And this is the direction we're sending in, so we're rotating it clockwise. And this means that we have a function now that we can rotate counterclockwise also. So if you want, you can add another key here that will rotate the Tetromino in the opposite direction. That's very easy to implement if you want to do that. I kind of play Tetris with just rotating it with one key, so I choose to not implement two keys for rotating in different directions here. All right, let's see if this works. And it does, that's nice. But if we go to the side here, you can see if we rotate it, it will rotate outside of the stage, and that's no good. And it will break it, as you see here. But it's rotating nicely. We're going to fix this thing now, so it can't rotate outside of the stage. So go back into our code, and inside our usePlayer custom hook, and inside the player rotate function, we're going to continue to write some code here that will solve this problem for us. And this one, I actually grabbed it directly from the Math method tutorial, because I think it's very clever how he does this. So this code is straight from that one. First, we want to save our position in a const. So we have const pos equals cloned player dot pos dot x. So that's the x position we save here. Then we're going to create a new let that we call offset, and that equals 1. Then we're going to have a while loop. So we have while, and inside the while we check collision. We send in the clone player, the stage, and we're not moving it anywhere, so we just give it 0 values in this object here with the X and Y. We already imported the check collision up here, so we don't have to do that again. And now we're going to write some tricky code here, actually, and I'll try to explain it for you. If we go back into our game, I'll try to show you here. So let's just place a few of the Tetrominos here, and I'll try to explain it. If we rotate this one here, as you can see, it will move inside of these Tetrominos, and that's no good. And this little function we're going to write now is going to take, wait, I'm going to create another one here. It's going to take the Tetromino when we rotate it and move it right and left and right and left and check if we collide with something. And that's the clever little function that he came up with in that tutorial. Let's say we go right, it will check, are we colliding? No. Then we go left, are we colliding there? No. And then it will continue until we collide, or if we don't collide, we can actually rotate the player. So that is how this is going to work in this while loop. So we have our clone player, we set the position.x plus equals the offset. And this is how we keep track on how many steps we're moving to the side, back and forth. So we set the offset, it equals to minus parenthesis offset plus the offset. If it's greater than 0, we set it to 1, otherwise we set it to -1. And it's this little row here that will create the kind of back and forth movement for us with the Tetromino. Then we can create an if statement and we check if the offset is greater than cloned player.tetromino. And we grab the first value in the array and length. Here we're just grabbing the first row and check the length of that one. We don't need to do any more check here because we have looped through the complete length of the Tetromino. Then we just rotate the Tetromino back because this move isn't allowed. We can't rotate it. If we have tried this back and forth more than the width of the Tetromino, then we know that we can't rotate, so we just rotate it back because we already rotated it up here. So we just rotate it back. Rotate cloned player dot Tetromino and minus direction. We reverse the direction, so we rotate it back. And we set the clone player dot pos.x to equals position. And that's the one we saved up here because we want it to have the same position as we had from the beginning. And then we just return. So this is, quite a handful of a function. I don't blame you if you don't get it, especially this one. It can seem a little bit tricky. It took some thinking for me to understand this. Just think of it as this one will go back and forth and see if it collides with something when we rotate. And if we do, we can't rotate it that way. And it will constantly move it away from that one when we rotate. So we can save it and see if it works. We can try this out. If we rotate it now, you can see that it kind of pops out from the wall. It won't go through it. And also if we do some rotating here, you can't rotate through them, and that's good. So I actually think that this is the most advanced function in this tutorial because this is quite advanced. Don't blame yourself if you don't get it the first time. Just try out yourself, try to change the code, try to look at it, read it, try and change it again, and you will soon get it how it works if you don't get it right away. And if you get it right away, well, good for you, and see you in the next video. Okay, we have a kind of a functioning Tetris game here, just a few things left to do. If we take a look here, we see that we have some full rows here and they should be swept off the stage and it should give us some score. at the end. But it won't do that now because, we can just fill this up and nothing will happen. In this video, we will create the function that will kind of sweep the stage and see if there's any rows that needs to be cleared and also push down the other ones that shouldn't be cleared. So that said, go into our code again and into our useStage custom hook. Inside of this custom hook, we're first going to create another state. So we create a state here that's called rows cleared. And set rows cleared. And this is how we're going to keep track of all the rows that we have cleared. So we use state and give it an initial value of 0. Okay. And the first thing we want to do in this useEffect is to set rows cleared to 0. And then we're going to create another function here that's called sweep rows. We're going to give it a new stage to sweep. And it's going to be an implicit return for this one, so we don't have to have curly braces. We grab our new stage and we're going to do some reducing here. So reduce. This is the built-in reduce ES6 function. We have the accumulator and the row arrow function, curly braces. So we give this function a stage and we're going to map through it with reduce. So we do that with new stage.reduce and we get the row and the accumulator. If you don't know how reduce works, I suggest you look it up. And the first thing we have to do now is to check if our row just contains cells that are merged. And that means that we can check if a row don't contain zeros. And we can do that with find index. So if row find index, we have our cell and an inline function. We check if the first value in our cell array equals to 0. And if this one equals to -1, we know that we haven't found a value of 0, and then we know that this is a full row and should be cleared, because find index will return -1 if it don't find a match with the provided function inside of it. If we're looking for the value 0 and it won't find that one, then it will return -1, and then we know that this row should be swept away from the stage. So we first set rows cleared, and we do that with an update the function because we're going to need the previous value, and we just add 1 to that one. Then we're going to grab the accumulator. That's the new array we're building up inside of this reduce function. We're going to unshift, and unshift let us add a new value to the array at the beginning of the array. Because if we look here, if we, for example, remove these 3 rows here, we need to add 3 rows at the top, and we can do that with the unshift method. So we remove these 3 ones here, and if we add 3 empty ones up here, it will push down the other ones, and it will kind of create the illusion that these ones just pop out of the stage and disappear. So with the unshift, we can add a complete empty row at the beginning of the array. So we create a new array from our new stage 0.length that will give us the width of the actual playfield. And we fill it up with an array of zeros and clear, because these ones are completely fresh. So they should be a 0 and clear. Then for each iteration inside of the reduce, we have to return the accumulator also. And this is if we find a matching row that should be cleared. If we don't do that, we just push the row into the accumulated array. And we return the accumulator again like this. And we could also give it an empty array to start with. So this is the complete function here. I will go through it again and tell you what it will do. We give this function our stage, and we take the complete stage and use the reduce method on this one. By using reduce, we can create a new array. So we check if the row contains any 0. If it does, we know that this row shouldn't be clear because we haven't filled up a complete row. But if we have filled up a complete row, we first add a row to our row's cleared state. Then we add a complete empty, a new row at the top of the array, and we return the accumulated array. This works because we completely ignore to return the full row that we should remove from the stage, and instead we return a new empty row at the top of the array. So this will create the illusion that we remove the row on the stage and move the other ones down that was above that row. And if we don't have a full row, we just return the row as it is in the array, and that's the way it works. We have to use this function somewhere, and we can do it. If we know that we collide with something, we should do this sweep and see if we also have a full row. So below the reset player, and because this one returns a complete new stage, we also need to return the function and give it the new stage. So this one will take our stage we create here when we have done all the mapping with the Tetromino and everything. And if it collides, then we call the sweep rows with this stage. And this one in turn will return another stage for us when it has swept all the rows and check that there's no full row that needs to be removed from the stage. Okay, so we'll see if it works. I have to do some gaming here to get a full row. And that's nice to be able to play some game here. Let's see if it works. And it does. Nice. It's kind of easy now when it's not dropping. Yeah, and we know that it works now, so I don't have to create another row here. And we actually forgot to do something here and go back into our code and into our useStage custom hook. We also need to return our rows cleared because we're going to use this one in the Tetris component later on. So make sure you add that one to the return statement here. All right, so that's it. We'll continue by creating the interval for the Tetrominos to drop by themselves in the next video. We are going to set this game in motion, and I think it's better we take a look at Dan Abramov's site first, overreacted.io, and then he has a blog post that's called Making setInterval Declarative with React Hooks, and it's 16 minutes read, so I won't go through it here, but I suggest you read this one because here he explains why it isn't a good idea to just use setInterval with React Hooks. So he has created this custom hook that's called useInterval that we are going to use, and hopefully you copy this file over to your project folder as I showed you in the beginning of this tutorial. Here's all the answers to why setInterval is not good to use as it is with React Hooks. It's better to create a custom hook and use that one instead. And one thing why it's not so great is because React hooks are heavily using closures, and closures can be quite difficult to grasp if you're not that used to them. He has created this useInterval for us that we can just use in our game, and that's what we're going to do now. So back to our app and our code. Inside of our Tetris component, we're going to be in that component in this video. At the beginning here where we import our custom hooks, we can import our useInterval from /hooks and useInterval. And that makes sure that we can use this one inside of our component. Okay, and now we're going to make this one move by itself, because now we can just drop it by pressing the down key on our keyboard. And that's no good, we want it to move by itself. So we can set up this interval, and below, I think, yeah, here somewhere, we can use our interval. So useInterval, and this one will take an inline function. So we create an arrow function. And we are going to call the drop function as we created up here, because that's the one that makes the Tetrominos drop. So we call that one. And we can specify the interval timing here. And we already have a state that's called drop time. So we just send this one in to the useInterval, because if we look at the useInterval, it will take a callback and a delay. And the callback is the inline function we created, and the delay is our drop time. So that's how this works. And also, if we send null into the drop time, it will stop and clear the interval. So that's good for us, because that way we can control the interval. All right, back to the Tetris component. We have to do a few more things here to get it up and running, because now our drop time is set to null. We set it up here. So now the interval is not active, but we have a start button. So when we start our game, we can set our drop time, and we send in 1000, that means 1 second. And we save it. And then if we press start game, as you can see, it's moving really good here now. And that's nice, because now we have a working Tetris game. Great. I want to do a few optimizations here also. We created one extra function here that's called drop player. And inside now we're just calling drop. And that's when we press the down key on our keyboard. I want to stop the interval when the player moves the Tetromino down with the keyboard. And that's easy. We can just set drop time to null. And that will make sure that we stop the interval. But we also have to activate it again when the player releases the down key. So we're going to create a new function here that's called key up. And inside of this, we're going to take in the key code again. So we destructure that out from our event. And yet again, we're going to check if the game is not game over. And we can activate the interval again when the player releases the down key. So inside of here, we check if the key code equals to 40, that is the down key. We will only run this if the player is releasing the down key. Then we set the drop time. For now, we just set it to 1000 again. We are going to create different speeds here later in the next video. So that's our callback function for our key up event. And we also have to make sure that we have this event here. And we can create it on our style Tetris wrapper. So we just add on key up, and it equals key up. And a little nice formatting here. And we save this one. And we can actually do a little console logging here, because here we can console log interval off, and we copy this one and go to our key up, console log interval on. Make sure you're showing your console here. Whoops, I misspelled this one. Yeah, my formatting here has added this one for us. Yeah, that's nice. So I can remove this one. It should only be useInterval here. Okay, so we start the game. And I press the down button. You can see that interval off. And then interval on when we release the button. And that's great, because then it will not interfere with the keyboard. When we hold the key down, it will repeat itself and make the Tetromino go down faster. And that could mess things up for us if the interval also is activated then. So that's actually all there is to it to create this movement, this kind of game loop that makes the Tetromino drop by itself. In the next video, I'm going to conclude this tutorial, and we create some nice little displays here with score and rows and level. And we're going to do that by create our last custom hook. We're almost finished now. We're just going to create our custom hook for displaying scores, rows, and levels. And we are eventually going to import it here in the Tetris component with the other hooks here. But we will create it first, so we have something to import here. So inside our hooks folder, create a new file that's called useGameStatus.js. And we're going to need a few things here. So we import useState, useEffect, and useCallback. from React. Then we export const useGameStatus. And we're going to need one parameter here that's called rows cleared. That's the one we created in our useStage. We're going to send this one in to our useGameStatus because we need it when we calculate our score and set the total rows that we cleared. Because this one here is just the rows that we cleared in the current render. That's why we set it to 0 here. So we clear it on each render. And then we're going to send this one in to the useGameStatus where we can add it up to the rows we already have cleared before. All right, we have an arrow function and curly braces. And then we're going to create 3 states here. So we have a const with the structure out score, set score equals useState. And we have a 0. We can just copy this one, paste it 2 times, and we're going to call this one rows and set rows. And we're going to initialize all of these with a 0. Then we have our level and our set level. So there you have it, 3 states. Then we're going to need a const that's called line points. And this is going to be an array with 40, 100, 300, and 1200. And these are the actual scores. I did some Googling and found these scores from the original Tetris game. So we're going to use these to calculate our total score. I don't know, there's probably a lot of different versions, so I don't know if this is legit, that it's truly the original scores that we used and also the formula for calculating the score. But I found this one, I think it was on Wikipedia actually. So you can have what scoring you want here if you want to change it. So we have a const that's called calc score. And this is a function we're creating here because we're going to call this function in a useEffect. And we're also going to need a useCallback because otherwise this will go into an infinity loop and that's no good. And I think that's also not a problem, but I think it can be annoying because it's easy with React hooks to make them go into an infinity loop if you don't think about that very, very thoroughly. Okay, so first we're going to check if we have score. If rows cleared is greater than 0, that means if we cleared any rows in the render, that's the one we send in here. Because if it's 0, we didn't clear any row, so we don't have any score calculations to do. And that means that if this one is greater than 0, we know that we cleared some rows and we're going to calculate the score. And if it's 0, yeah, we know that we didn't clear any rows in this render and we don't need to calculate any score. We are going to calculate our score and set our total rows. So I create a comment here. This is how original Tetris score is calculated. So this is the formula I use. I found that one on the internet and I'm using that here to calculate the score. So we just set our score state, set score. We have a previous state and we use that previous state to add something to it. And here's the formula. We have the line points. That's the array up here. And this line points array have 4 different values here. And they each represent 1 row cleared, 2 rows cleared, 3 rows cleared, and 4 rows cleared. And this is an array, so the index starts at 0. So we have to take our rows cleared minus 1. Because say, for example, that we cleared 2 rows, we need to grab the value with index 1 in our array. And we're going to multiply that with our level plus 1. And that's also because our level starts at 0. So that's why we're adding 1 here. So this is the formula to calculate our score. And then we also need to set our rows. We have our previous state here. And we take the previous state and add the new rows cleared to that one. And that will always keep track of our total rows that we cleared. All right. And as this is a useCallback, we have to make it depend on something. So we have the dependency array here. We have the level, the line points, and the rows cleared. So this one is always going to change when the level, line points, or rows cleared are changing. Otherwise, it will stay the same, and that's why it won't go into an infinity loop, because if we didn't have this useCallback, it will change every render, and that will create the infinity loop. Okay, and then we create a useEffect. We want this to fire off automatically. And this dependency array is going to depend on the calculate score, the rows cleared, and the score. We're just calling the calc score here. And as we're using these ones in this function, we have to specify them as dependencies here. But then we have to return something from this custom hook. So there's a lot of things we're going to return here. We want a score, we want a set score, because we want to reset the score when we start a new game. We need the rows, and we also need to set rows. We want to set the rows to 0 when we start a new game. And also the same with the level. So we want the level and the set level. Like so. So we save this one and go back into our Tetris component. We import it, where we import our other custom hooks. Use GameStatus from ... hooks use GameStatus. All right. Then we have to use these values inside of our Tetris component. But first we have to call our useGameStatus hook. We can do that below here. So we have a const, and we are going to receive everything that we returned from this one. All of these here, we're going to receive here. So we have to specify them. We have the score, set score, rows, set rows, level, and set level. And we're going to call our useGameStatus. And we're sending in the rows cleared, as we talked about before. And of course, we also have to grab the rows cleared here from our useStage hook. See if I can make it a little bigger here. I think we actually can move this one down here to make it a little nicer looking. Like so. Okay, and now we have to use these values inside of our Tetris component. First, in our drop function, we want to change the level depending on how many rows we have cleared. And that means we have to have something here that calculates that on every drop. So I make a little comment here. Increase level when player has cleared 10 rows. I think that also is the original Tetris, but I'm not sure. When you clear 10 rows, then we go up a level and the speed will increase. We create a little if statement here. We check if the rows are greater than level plus 1. That's because the level starts at 0, just as before, times 10. We set the level with our previous state, and we just have the previous plus 1. We're just increasing the level by 1. And we also want to increase the speed. And this little formula I created here, I don't know if it's optimal actually. I'm going to set the drop time like so. And then I have 1000, that's 1 second. I divide it with the level plus 1. And then I just added 200 here, so it will not get too fast. And you can actually play with this and try another formula and see if it works better for you. So I don't know if it's good. I think, yeah, it's working fairly nice, but yeah, probably there will be a better formula for this to use. So that's how we calculate our level. We can actually also set a few things here when we start the game, because we also want to reset our score level and rows. So we can set our score to 0. Set rows to 0, and we set our level to 0. And then there's one more thing we have to do here. We are going to take this formula here and copy that in the drop function, where we set the drop time. We have to also paste that in our key up function, because now we're just setting it to 1000 here. So just paste it in there. And we want to display our score rows and levels also, so we can change these ones inside of the props we're sending in to the display components. So we create curly braces, double ticks, and we have our score and a $sign and curly braces, and we grab our score. Then we do the same with the rows and the levels. We can copy this one, paste it in, and then we change these ones. We have our rows, and we have our level. So this will make sure that we display the score rows and level. And I think it's time to save this one and see if it works. So it's already displaying the zeros here, so we can start the game. And it seems to be working nice. So that's it. We have a working Tetris game. I just want to make a little optimization here, and I'm going to show you why. Because if we go inside our cell component, and for now I have to do like this because I want to console log something out. Re-render. So what I'm doing here, I'm just going to console log out re-render on each cell here. So I save this one. And as you can see, we have 240 re-renders here. And that's fine when we build this table for the first time. But as you can see, on each little drop here now, on each rotation and everything, we get 240 renders. It probably won't be an issue here because React is fast. But I want to show you here how you can create a little optimization for this one. So we go back inside our cell component, and where we export this one, we're going to export it with React.memo. And this will make sure that it memoizes this cell component and only re-renders when the cells actually are changing. So we save this one. And as you can see, we're just re-rendering the cells that actually change with the Tetrominos now. And I actually think that this is a really good example to show you what React.memo does in React, because now it won't affect the cells that won't change on that render. It will only re-render the cells that change with the Tetrominos. And that's good. So we made quite an optimization here and reduced the re-renders here, and that's good. There you have it. This is my version of Tetris with React hooks. And as I said a couple of times now, I'm not a game developer, but it was sure fun to create this game. And I think it's a good practice in React and especially React hooks to see how they work. And I hope you enjoyed this one as much as I did. And I'm very grateful that you have followed me on this tutorial, and I hope you learned a lot. I initially created this one exclusively for freeCodeCamp. And I actually record a lot of free stuff, especially in React and frontend and stuff like that, in my own YouTube channel. So if you go to YouTube and just search for Weibenfalk, Weibenfalk, you will see my pretty face here, and you can just go to my channel and make sure you subscribe if you want free coding tips in React and other front-end stuff. And I also create paid premium courses. I'm going to move them to my own platform soon, but for now they're up on Udemy. And it's a beginner React course and also a course in Gatsby and how to create a Gatsby site with WordPress as a headless CMS. There's also a free course on React Redux. And there's, of course, the hooks introduction course that were published on freeCodeCamp a little while ago. And I'm also on Twitter. Just hook me up there if you have any questions or just want to follow me there. And I sure appreciate the support I can get from you. I want to continue to create free stuff and do things like this. So hopefully you'll see me again in another video. But for now, thank you and goodbye.